Hi students, today I'm going to explain the waves second class it is. So in this class we are going to discuss about waves and wave function, and let us do some problems and understand what is a wave function first of all. Okay, in the first class I have explained about what are waves and what are the types of waves, what are the wave parameters and everything, right? So now let us discuss about wave function, which is somewhat important to understand. It's conceptually most of us will get confused about wave function, but it is very easy to understand. It is very easy. Wave function. Okay, what is a function? It's nothing but, see here, if we are writing, suppose if an object is traveling from one place to another place on a straight line, if it is moving with uniform acceleration, then you can write S is equal to, then you can write its displacement as S is equal to ut plus half a t square. Yes or no? Ut plus half a t square. See here, this is what, here S is a function of t. S is a function of variable t here. Means displacement changes along with the time here. Am I right? Now, in the same way, means what does it represent actually? It represents that a particle is moving with some acceleration and we are finding out the displacement of the particle. Okay, with a uniform acceleration, right? Now, in the same way, if we want to describe the motion of a wave, then we should write a function, okay, which denotes the position of a wave or position of the particle in a wave, which denotes the position of the particle in a wave. Means after what time, what is the position of the particle and what is a displacement of wave. Okay, everything if you want to understand, then we should know about this wave function. What is a wave function here? See, let us discuss about this. So in this wave function, let us take a simple example. Suppose if not a wave, it's not a continuous wave, it's simply, I am assuming that a pulse is generated with the help of a rope. Now I'm taking a rope, now I'm giving a jerk to it in the up and down, upward and downward directions, so that one pulse is generated, and that pulse will travel with a certain velocity v. That pulse will travel with a certain velocity v, so that the particles which are there on the rope, they will move up and down as a wave is disturbing that particle. Okay, so here now let us take first, if the particle is at this position, see here, now let us suppose I am drawing a pulse which is generated in a rope. I'm drawing a pulse which is generated in a rope. Okay, now if this is a pulse, then after some time what happens, it goes to some distance, this pulse goes to some distance. Okay, now then here the particles in the rope will move in y direction, so that this pulse will move along x direction, this pulse will move along x direction. Am I right or not? As I have already told you in the previous class about uh, transverse waves. Suppose if a wave is going like this and the particles will oscillate up and down. Am I right or not? Now I'm not going through waves here. I'm just taking one pulse. That's it. See, if we give a jerk to it once, then one pulse will be generated. if we give the text continuously, then what happens? Waves will be formed. Continuous waves will be formed. Am I right? So that's why, see, this is a, suppose if this is a velocity of the wave, or if this is a velocity of the pulse here, then what happens? This is going to some distance. Let us take from this position to this position. Okay, then what will be the distance from that to that position? Assume that it is v into t. It is v into t. The distance from this position to this position is v into t. See here, how do we represent this total wave motion or motion of the pulse here? How do we represent? By taking the displacement function, that is y is equal to, or else y of x comma t. We have to represent this with y of x comma t. Okay, now see, this is a function, right? Which means that y has to y has to be explained in terms of x and t. Okay, now so if at t is equal to 0 seconds, at t is equal to 0 seconds, wherever the pulse it may be, then we can write it as y of x comma 0. Okay, now we will write it as y of x comma 0. Let us take that y of x comma 0 is a function that is f of x. F of x means it is completely, it is purely in x. Okay, now why? Because t terms are 0, and after some time it has gone to the same position. Suppose after uh, after some t time, if this particle or if this wave is again generated here, then we can write that here y will be okay now same again after how much distance? Again after x minus vt. Means suppose if it is traveling with a wave, then y will be same again after x minus vt distance. How can we say? See here, if we consider this is x minus vt, it means that at t is equal to t seconds, at some t seconds, after some time t seconds, then we can write it as y of x minus vt. So here y of x minus vt is again equal to y of x comma 0. When is it possible? Here, if y is maximum, okay now, if y is maximum at 0 seconds, then again after, okay, or y is maximum at x distance, y is maximum at x distance, then again y will be maximum after x minus vt distance. Y will be same, or y will be maximum after x minus vt distance. Maximum y means what? It is nothing but it is the amplitude, yes or no? This is maximum value of y maximum, which is nothing but its amplitude. Which is nothing but its amplitude. See, so when do we get the maximum value? Suppose if we get at x distance, if we get the maximum value of y, then again after x minus vt distance, we are going to get the same value of y. We are going to get the same value of y, means the same maximum value of y. How can you say? See, and also if it is x minus vt, okay, now here it means that okay, particle is moving, I'm sorry, wave is moving, along positive x direction. Positive x direction. Wave is moving along positive x direction. Suppose if it is x plus vt, then what does it mean? It means that it is going along negative x direction. Wave is traveling along negative x direction. If it is y of x plus vt, y of x plus vt, then it means that wave is traveling along negative x direction, which means that from the origin, if this wave is traveling in the negative x direction with a velocity v, then we can write it as y of x plus vt. Means at x distance, suppose if y value is maximum, then after x plus vt distance, again y value will be maximum. Okay, now how can we say this? There is a proper equation, or there is a proper expression which explains about this pulse here. Now I am going to explain this entire thing by taking the general equation of this pulse, that is general equation of the pulse, or the general expression of pulse. Observe this carefully. General expression of the pulse, that is y is equal to a by b plus x plus or minus bt whole square. This is the general expression of the pulse here. Okay, now I'm writing the general expression of the pulse. Then if we find out the x values and its corresponding y values at a time, okay, now at a certain time, then if we plot a graph, then we will get automatically this shape, means the shape of a pulse here. So this is a general expression of the pulse. Now I will tell you how do we get the pulse with this equation. How do we get a pulse with this equation? Now I will tell you. Now let us take one example. Let's take one example and I will explain. Right now, see here this example, a wave pulse is traveling along positive x direction. Now a pulse is generated and is going along positive x direction on a string at 2 meters per second. Displacement y of the particle at x is equal to 0 at any time t is given by y is equal to 2 by t square plus 1. See, I have already told you that y will be in the form of, in a general equation, that is a by b plus x plus r minus vt whole square, right? Now I'm going to take a function y is equal to 2 by t square plus 1, and now I'm going to find out the expression of the function y is equal to x comma t, that is the displacement of the particle at position x and time t in terms of v here, because v is already given here. V is equal to it's not meter, it is centimeter per second. Let us assume that it is centimeter per second, whatever it may be. Okay, now let us consider this first one. If we take y is equal to, let us take the given function 2 by t square plus 1. Now we are going to find this function at t minus x by v, at a time t minus x by v. What is t minus x by v? Here x by v is nothing but what? It is also time only, no? Displacement by speed. Displacement by speed is nothing but time. Am I right or not? So within a time interval t minus x by v, now I'm going to calculate this y value. Now I'm going to take this y value at t minus x by v time, so that we can write it as at t minus x by v time interval, I'm going to write y as 2 by, means I'm writing this in terms of x and v also, right? 2 by t minus x by v whole square plus 1. Okay, now after t minus x by v time interval, I'm going to write y is equal to 2 by t minus x by v whole square minus 1, so that we will get it as 2 by, now what do we get? See here, t minus x by, what is v here? V is given as 2 whole square plus 1. Means after t minus x by v time, okay, now it is going to some distance. Okay, now let us see this carefully. So that y value we have got it as 2 by t minus x by 2 whole square plus 1. Now in this function, now let us substitute t is equal to 0. Means at 0 seconds, what happens to this y value? Let us check. At t is equal to 0 seconds, then y naught means initial displacement. Let us take, okay. Y naught will be equal to 2 by okay, t minus x by 2 whole square, in this t value 0, therefore minus x by 2 whole square is nothing but x square by 4 plus 1. X square by 4 plus 1. This is what y of x comma 0. This is y of x comma 0. This is y of x comma 0. See here, y of x comma 0, it is written in terms of f of x. It's a function of x now. Now, see here, now it is a function of x. Therefore, at each and every x value, we are going to find out y value. Okay, so when can we say that y is maximum? Y is maximum when x is equal to 0 only. Why? Because in the denominator value, if it is less, then see here, if x value is 0, then 0 by 4 is nothing but 0, and hence you will get the maximum value of y. Am I right or not? Therefore, at x is equal to 0, then we will get y is equal to 2 by 1, which is 2 centimeter, which is y maximum. Maximum displacement. Particle goes to maximum displacement. So where is the maximum displacement? At x is equal to 0, already it is at maximum displacement. Okay, now particle is at highest position. Then what happens to at x is equal to 1? X is equal to 1, y value can be written as, okay, now then 1 by 4 plus 1 means it is 5 by 4. Am I right or not? So if it is 5 by 4, then you will get it as, then what do we get? If it is 5 by 4, 2 into 4 is 8, 8 by 5. 8 by 5. 8 by 5. 8 by 5 is less than 2 only, no? Right, 8 by 5 centimeters. At x is equal to 2, at x is equal to 2 centimeters, then what is the value of y? See, it is going on, it goes on decreasing. See here, y value. Let us take it as y1 and let us take it as y2. So again, y value at x is equal to 2, we can write it as 2 square means 4. 4 by 4 it is 1. 2 by 2 it is 1 centimeter. So what are we getting here? Slowly its value goes on decreasing. Its value goes on decreasing. Similarly, on negative side, if we take at x is equal to minus 1 or at x is equal to minus 1 centimeter, it's negative side of, okay, wave. So that at x is equal to minus 1, then we can write here y minus 1 is equal to, then what do we get the y value of this? Then you will get it as, again, same thing. Why? Because x square is there. Therefore, we will get a positive value, and again, you will get 8 by 5 centimeters. See how we are getting the same values? Even at x is equal to minus 2, whatever the value of x, it may be plus or minus, we are getting the same values. See here. You can again get 1 centimeter only. So if you plot a graph of this one, if you plot a graph, if you plot a graph of this one, then you will get at this point, let us consider this is the origin. So at x is equal to 0, this is x-axis and this is y-axis. This is x-axis and this is y-axis. So at x is equal to 0, what is its y value? Its y value is 2 centimeters, which is maximum. At x is equal to 0, its y value is 2 centimeters. Okay, na? And this will be y maxima, which is equal to 2 centimeters. Now, after 1 second, or sorry, after 1 centimeter distance, positive values, after 1 centimeter, then what is its value? Something it decreases. How much? 8 by 5. And after 2 centimeters, y value still it decreases. Yes or no? Still, y value is how much? 1. Y value is 1. So that sorry. So here at x is equal to 2, you will get y value as 1, so that you will get a like this. Means finally you will get a curve like this. If we add all of them, you will get a curve like this. If we take all of them, you will get a curve like this. Am I right? See? Why? Because if you take different values of x and y values, so that you will get a curve like this. What is this curve? This curve replicates, you know, it is what it's just a pulse. Am I right or not? It is in the shape of a pulse. Am I right? So with this, we have proved that whatever the function it is there, that is y is equal to, whatever the function it is there, that is y is equal to a by b plus x plus r minus vt whole square. If any function is in this form, then we can say that it gives you actually what is, I mean, it gives you which shape? It is a pulse, general equation of a pulse. Then in this pulse, how do we find out the amplitude directly? Directly, amplitude can be found as amplitude is equal to a by b. Even here also you can check what is amplitude here. A by b means 2 by 1 in this example. 2 by 1 is nothing but 2 only, no? That is what we have got the amplitude, means maximum displacement, right? So that's it. Now in the next video, I will take another example and I'll explain you how it travels. Means suppose if we want to find whether it travels along positive x-axis or negative x-axis, we have to do, if it is x plus vt, then it will be along negative x-axis. If it is x minus vt, then it will be, then the wave is traveling or the pulse is traveling along positive x-axis. Okay, now let us know that in the next video. I will tell one more example. Okay.